Good morning, everyone. My name is Pensu. I come from TU Munich. Today, I want to talk about our work, which is about the malware detection and categorization with network traffic images. This work is cooperated with Claudia Eckert. She is my supervisor in TU Munich, and also the apostolate skills from the Delft University of Technology. The name of our work is Falcon. The agenda of our talk includes introduction. Here we will talk about our motivation and also our contribution. Then we will talk about the related works in the malware detection field, which will include the feature-based, configure file like the permission-based, and also the program code-based. Of course, we will talk about some work related with the network traffic-based malware detection system. And then we will talk about our system design and also the implementation. The evaluation part will be followed. And then here we will talk about the methodology we used to collect our dataset and also our compared result with another related works. And the one part of this talk will talk about our limitation, which includes the small data set and also another type of the limitation. Last but not least, we will talk about our conclusion at the end of this talk. Introduction. Currently, NG is the main target for many type of the attacks. Some type of the attack like the seeding, spam email, spam new malware, and also the generate malicious advertisement. However, in this field, there are also many works which focus on the malware detection and the categorization for the Android platform. Among those methodology, we can cluster them into the two type of the feature prepare. The first one is the static feature, which includes like the API call based methodology, permission based methodology, and executable binary, executable file and pattern based feature. On the other hand, we also use a dynamic feature based methodology, like the dynamic feature from the network traffic and also the system call tracing as a dynamic feature. And also we also have the log file based dynamic feature. But here, we just put the log file based system into the system call tracing based methodology because they have the very common methodology, common techniques to be used. For the static analyze, actually, it's easier compared to the dynamic, but it also has some problems. For example, we cannot detect the hidden vulnerability and malicious, which evicted by the third-party library runtime. It means we cannot detect this type of detect this type of malicious at runtime. But for the dynamic analyze, we also have some two directions. The first one use the menu features like the point, IP address based methodology. The feature of this type of the methodology is very simple and also, of course, very effective. But if we use some obfuscation methodology to hidden the malicious IP address, malicious point, we cannot detect this type of the malicious behavior. For the system call based methodology, it's because we should record all the information from the log from the system call. So that means the methodology is very expensive and also inefficient. In this case, follows the two problems. We present our work Falcon, which is based on the dynamic analyze, but it's effective compared with a system call. And also, on the other hand, we also use the representation learning, extract feature from the network traffic itself. We didn't use the manual feature like the point or IP address, something like that. So our contribution can be summarized as follows. First of all, we present Falcon, that is the network traffic pattern-based Android malware detection. On the other hand, detection and categorization framework. On the other hand, as the second contribution, we design a bi-direction LSTM network which is used to do the image 2D image sequence classification. Here, I mean, in our work, we can see the network traffic is the 2D image sequence. Yeah. Third of our contribution is summarized. Is we create and realized a dataset. The name is AndroNet MNIST, which includes over 3 million 3D 2D gray image in 5 class. And the last but not least, we evaluate our framework on the real world data sets. The result is very good. So for the later work, we will talk about some is the many type of the methodology used to detect malware. First methodology is the feature code-based methodology. This is very simple and also very effective methodology. But the problem is that it cannot find out the no-seen malicious, because we get the feature code from the malicious itself. So if we meet the unsealed malicious, we cannot get the feature in advance. So that means we cannot detect the unsealed malicious. With the development of the machine learning and deep learning in our field, I mean the malware detection field, we also use the machine learning and deep learning techniques. First of all, if we use the malicious API in the Android manifest file, we can also construct the malware detection system based on the malicious API. At the same time, if we get the permission from the manifest file, we can also construct the machine learning-based malware detection system. The third consideration is we directly get the feature from the program code itself. Some method like the control flow get from the code, and also the API call, function call get from the directly get from the program code. Last but not least, we can also get the feature, another feature like the byte sequence from the program code. Byte sequence, it means it consists of the machine instructions sequentially, and use the methodology from the natural language processor to consider the binary, rough binary, of suitable binary. The last methodology, the last direction is the network traffic-based methodology. Actually, our method is also here. Yeah, after talk about the related work, let us move to our design and implementation. Here, figure 1 represents our framework. We get the input from the network traffic, and then our purpose is class to do the malware detection. That is the binary class problem, and also the malware categorization. That is the multi-classification problem. Here, D it means the detection, and the CA means the categorization. We also have the bidirection STM to construct our feature vector, feature embedding here. Feature FV means the feature vector. So this part is the feature preparation, and here we also have the image to vector part, and also the flow from the follow and from network follow to the image generation. We will talk about all of the module of the module in detail. The following text. Here, for the feature extraction, we also include several parts. The first part is convert the network traffic to the network flow. So from the network traffic analyze, we had different level of the network to analyze. The first one is the packet, and the other one is the follow, and the third one is session. How can we define the network follow? If we have the network traffic, and also, I mean, the network traffic, it means that we have the source IP address, source port, and the destination IP address, destination port, protocol. If the network traffic has the same, this file tuple, we define this one is the same network follow. Yeah, here, network follow 1, network follow 2, if they have the same file tuples. Yeah? If we get this network follow, and then we do the next step, transform the network follow to the image. Here, we defined our image. The size of the image is 784 bytes. Of course, we can change this number. If the network traffic follow, the size of the network follow is not is not bigger than this number, we can use the padding methodology. If the number is over this number, not over 784, we can use the triming methodology to cut the size of the network portfolio. Except prepare the image, we also prepare our labels. Here, in our case, in our work with the file class 1B9 and for malicious classes to define our labels. After that, we get our feature generation. Feature generation here we use the iterator. Here after converts follow to the image, we use the convolution neural network. Here we use the 8 layers convolution neural networks. First one like the convolution, relo, max polling, convolution, relo, max polling, and the 4 connection. Our output is the 5 classes. The network, the size of the network is like, so we have the 70,000 total parameters. Here we use this equations, these equations. Those equations define our network, convolution neural network. From here, we can get the pro-training model. Yeah, we talk about how to convert the network to image, and then we use our pre-training model, image to vector, convert all of the image to the vector. And here we can see this our network traffic, is the 2D sequence image classification, like the one network package include multiple 2D images, and then we use the bi-direction LSTM network to get the final vector for a whole network package. We use a network traffic container categorization. Continuous is getting from the binary direction STM network. The last step of our network, our framework, is the model training and the prediction. Here we use category crosstalk entropy loss function. Here WE and WI1 and WR2 is the value for our class 5, and the B1 and B3 is offset from the original of the vector space. Here, yeah. Right offsite. This is our label. Okay, after talk about our framework, let us move to the evaluation part. The first part of the evaluation is talk about the experiment setup. Here we use the TensorFlow and the Keras as our network machine learning framework, and we also use the split cap, which is used to convert the network traffic to the network follow, and then use the payload, which is converts the like the network follow as a binary sequence to the image sequence to the image, and except that we also use the skyline and also the multiplier label to construct our framework. For the dataset, actually we got our dataset from the image sequence and also to the image from the 226 malicious in 4 families, and also the 1,700 binary samples. We split our dataset with 80% for the training and 20% for testing. So that means in total we have the 2,126 pickup file, and we use the split pickup to get this number of the network network image, network follow convert to the image, and this is the number for the benign traffic. In total, we get the more than 3 million network traffic, network follow. That means we get the network images. Our result for the malware detection, here we compared our work with another related work like the Adagio driving and also the CRC 2017. Here we can see use the Falcon just consider all of the network traffic is a split network image, we can get the best result. If we consider that is the 2D image sequence, we can get also the very good result, but worse in the Falcon. Here, I mean, for the Falcon, for the last classifier, we use the random forest and set the like the n is to 1040 and also the sample split to 5. The reason why the CNN network is better than the Falcon because here Falcon CNN cannot determine the whole network traffic character because it's like the split all of the network to the image to the image. So that means if we just use the CNN network, we cannot find out of the malicious behavior because mostly malicious behavior are hidden in very few network follows. So yeah, this is the difference between our two networks. For the malware categorization, we also consider the whole network is the 2D and the 2D image sequence. We can see from here, if we consider the network traffic to 2D image separately, we can get a very good result, but it's not the, it's not a continuous feature. If we consider the continuous feature, we can get also good result, but not very good. Yeah, except that we also consider use a different classifier in our system. I mean, by default, we use a random forest. Except that we also test on the ADA boost and the graph boost, MLP, and this entry. The setting, I mean, the parameters used, the parameters of those class are described here, and the result is here. We can say use the random forest, we can get the best result. The worst result from the MLP. Here, MLP is like this hidden 4-layer MLP, and another configure setting is here. So after the talk of our limitation, let us move to our limitation here. Actually, we have the two types of the limitation. The first one from the dataset. The dynamic network traffic dataset is very small. It's just have the 2,100 samples. And for the sample class, we only consider the 4 malware types. But for the malware detection, we have more than 100 and 200 malware types. And also time efficient, time consuming, more time consuming than point based because the point based method, it's like the matching, just use some very easy feature which are getting by the manual feature that is very fast compared to our work. Okay, let us conclude our work. First of all, we present Falcon, that is the network traffic based on malware detection and categorization system. We design a bidirectional LSTM network to compare 2D image sequence classification problem. And third of our contribution is we create and realize a dataset that is Android Amnist dataset, which includes more than 300 million 2D image, 2D gray image in 5 class. And we also evaluate our performance of our work, use a real world dataset. Thanks, and any questions and comments?